occurs at the origin. We'll just say, so that means like this is starting at 0, so 0 time and like the original position. So, so now we're going to pretend that we have another event R, which occurs somewhere other than the origin, and we want to see like under what conditions can we find for which like P and R occur at the same time. So if P and R occur at the same time, that means that they occur on the same. So if we were looking at like our axes here, like for the t prime axis, if it occurred at the same time in this frame, it would occur along the same line as P. So this would be along the x prime axis, and so similarly, like if it occurred at the same time as P in the just like the normal our home frame, then it would occur along the x-axis. So if you look at all the places where R can occur at the same time as P, so we will have like limits here. So it can occur here, it can occur here, but it can also occur at any points in between if we if we like expand and shrink our axes to fit that. So we have a limit here where the speed of light would be, where this dotted line is. So we know that like we can never really reach the speed of light because then like our axis is going to shrink. So that means that when we look at the area between the speed of light, like the sort of axis that we've drawn here, and the speed of light down here, that this is going to be something called the causal present, because that is where the event can occur at the same time as P. And I don't know. And this relationship can be called a space-like interval. Since like you know that like if R was here, like it'd be at a different place in space than P, but it would be at the same time as P. Okay.
We're good. Keep going. Keep going.
Now next, we're gonna see. Okay. Okay. So now we're going to see that if R is on the 45-degree line, this is called a light-like interval. And so if we had, let's draw another thing. Okay, so if we had P here, oh, it's really dark now. Okay, and R here. Okay, so if we had P here and R here, then so, like, the question here asks, what is the time and spatial difference between P and R? If something is moving from P to R, and this, okay, if something is going from P to R at the speed of light. So that means that, if you think about it, that means that the axes that the T prime and X prime axes that we have here, it would shrink. So if we drew in our T prime and our
push together.
It would like we'd move the axes in until like both axes are basically along this 45-degree line, and since our T prime axis shows time and this shows position, that means that the time and position would be the same exact place. So that means that R would occur at the same time and place as P.
Yay!
Yeah.